Welcome to the second tutorial about free and useful solutions that can help you generate VR walkthroughs of your architectural designs. Now, interest in using VR to experience architectural design has increased over the past few years, yet it's a rapidly changing area, and it can be quite a task to identify the best way to incorporate VR so that you and your clients can have a useful and enjoyable experience. Now, luckily, there are some really useful and very cheap, even free tools available that you can start using today. Now, once you have your model output from, for example, SketchUp, you can then use Lumion to convey your design in its real-life or conceptual environment. Finally, combined with free and easy-to-use tools like Sketchfab and Mozilla Hubs, you can generate VR walkthroughs and share them online. In our first VR tutorial, we saw how you can add realistic lighting and shadowing to a model of a house in SketchUp. We then uploaded it to Sketchfab, a 3D model sharing website with a VR viewing option built in. So with a wireless VR headset like the Oculus Quest, you can walk through your room design and get an impression of its space. If you missed that first tutorial, you can watch it by clicking the link in the video description. It's worth a watch, as a few steps in this tutorial will use techniques that we learned then. To work with larger 3D models, like the ones created using BIM software such as Revit and ArchiCAD, we'll need a different tool to bring them into VR, as Sketchfab's VR performance is too slow for larger models. In this tutorial, we will introduce another free web-based VR system called Mozilla Hubs, which can better process larger models. We will also show you some light mapping techniques that are needed for these larger and more complex 3D CAD models. Now, Lumion has no commercial or business relationship with any of the tools or companies covered in these tutorials. We simply spotted them on the market and felt that they were useful solutions that some of our customers would really appreciate. We felt it would be valuable to explain how Lumion and SketchUp users can easily add these free tools to their workflows, tools that can be especially useful when physically getting to clients is difficult or not possible. Alright, the first step is to look at how you can get your CAD model into Mozilla Hubs to create a smooth and impressive VR experience. In order to import, assemble, and prepare objects for use in Mozilla Hubs, Mozilla created an online tool called Spoke. You can access it by going to hubs.mozilla.com/spoke. And don't worry, we'll leave links to everything we cover in the video description. Once we're in, let's start a new project. In Mozilla, you start with a default environment called Créer. You can delete this environment by clicking it and using the delete key. Add a new model to the scene by dragging and dropping a model item into the viewport window. You can see at the bottom right-hand corner of the screen, the default model object has a URL associated with it. Delete this URL, as we're going to paste the URL of the house we made earlier in Sketchfab. Any object that you configured as downloadable in Sketchfab can be brought into the Spoke editor in this way. We can't see the model at first because its size was set to a default of 0.01. Let's set the size to 1. In the top right section, you can see all the items that are part of the default new project. Since our house has its lighting baked into its textures, we can delete the directional light and add a hemisphere light. This will light up the scene more evenly. Let's rename the project to Basic House. We can go ahead and publish our new project. Alright, our project is published and we can now view the scene. Let's create an online meeting room within this scene and call it Basic House 1. Click to enter the room. In principle, everything is ready for our VR headset, but to improve the experience, there are several tweaks we're going to do first. We'll show you these in a bit. First, let's take a look around our scene. Moving through the scene is like a first-person video game. This means that you can navigate using the Q, W, E, and ASD keys, or the arrow keys if you prefer, combined with the mouse. Holding the left mouse button lets you rotate and look around, while clicking the right mouse button instantly teleports you to the spot where you clicked. You can also invite other people to join you and check out the project. All they need to do is use the project's unique URL or temporary code in a browser, including the browser that you access inside a VR headset like the Oculus Quest. When another person enters the room, you'll see them added to the group icon at the top right corner. If the person entering the room is wearing a VR headset, you'll also see their hands, which correspond to the headset's controllers. Now then, with that quick tour done, let's improve our experience while in VR. Here's a view that we recorded while using the headset. The first thing that you might notice is that our eye level is too high. You can tell that the eye level is too high because when you try to touch the ground with the controllers, you'll see that you can't actually reach it. It almost looks as if we're on an invisible ground plane that is floating above the visible floor level. To understand why this is happening, we need to go back to the spoke editor. And if you look at the model properties at the bottom right, just below the URL, we can see that our model has the options of collidable and walkable. These settings will be very important moving forward. Click on the floor plan from the hierarchy list on the right. Then on the bottom right, click Regenerate. This will show the area where we can walk, as well as the objects that we can collide with while walking through the VR scene. These yellow lines show the collision boundaries throughout the house. This is called a collision mesh, and it was created from the objects in the scene that have the walkable and collidable options active in their properties. Another option is agent height, which you can set to your own height and eye level. The default collision mesh for our scene looks okay at first glance. Let's click on the Regenerate button. This is something you need to do whenever you make a change in the properties or when you set a mesh to be collidable or walkable. Upon closer inspection, we can see a blue transparent plane floating above the yellow lines on the floor, which seems to correspond with the floor level of the real-life room that you experience when walking in it with a VR headset. There's no way to lower this plane, but we can get around this problem if we generate the floor plan's collision mesh with an invisible copy of the house shifted 40 centimeters lower, in combination with a visible copy of the house that will have the options walkable and collidable turned off. The exact difference between the visible house and its collision mesh can differ based on the house design, and trial and error is often the best way to determine this number. It is also based on the accuracy of the boundary area height set by the Oculus Quest. To create the invisible and visible copies of the houses, let's add another model item into the viewport, and we'll give one of the houses a y-axis of minus 0.40, while the other house's y-axis will be 0. For the lower copy of the house, we'll keep the collidable and walkable options on, but then uncheck the visibility box. We'll set the house model at the higher position to visible, and we'll turn off the walkable and collidable options. Another way of achieving the same goal would be to add a simple custom-made object into the project. For example, you can make an object with only the house's floors and stairs using your 3D modeling tool. And when you add the object to this project, it should be the only object with walkable and collidable options turned on. This will not only improve the performance of the VR experience, but it will also make it easier for people to walk through the house without bumping into furniture objects. Now that our height is set, another thing we're missing in the scene is a nice looking background. Luckily, we can create one quite easily by dragging a 360-degree image into the scene. To do this, untick the Controls option and set the projection to 360 equirectangular. Increase the size to 50 and rotate it so that it fits better with the light and shadows in the house. And lastly, we're going to want to walk around the house, so let's add a ground plane that's wider than the building's exterior walls. We'll first need to go back to SketchUp and create a plane that's around 20 meters by 20 meters. Make sure to save the plane in a GLB file format, a relatively new file format seen as a successor of Collada. While GLB files are not widely used in the CAD industry, it is the only 3D format supported by the Spoke editor in Mozilla Hubs. So in SketchUp, you will need the GLB export plugin that's available in the SketchUp extension warehouse. You can find a link for this plugin in the video description. Once you have the square plane saved as a GLB file, simply drag it into the Spoke editor. It will appear in the section My Assets and in the Scene viewport. We will use this square plane as a collision object. To show a nicer ground plane, instead of this blander gray, we rendered a top view image of a meadow in Lumion, saved as a PNG file. We then used Photoshop to fade the image's edges and dragged it into the scene. Untick the controls option, keep the projection flat, increase the size to 20, and rotate its x-axis to -90 degrees. Finally, align the image to our newly added square plane. Select the square plane again, adjust the y-axis down by 30 centimeters, and set it to invisible. Regenerate the floor plan and publish the project again. Now, when we enter the room, our eye level looks a lot better. We're no longer floating in the air, and we can touch the floor with the VR controllers. They actually seem to touch the ground. With these tweaks out of the way, we're going to move on to a more interesting and complex CAD design. This house was designed by Dutch architect Paul Spaltman, and it's being constructed right now at the time of making this tutorial. Paul used ArchiCAD to design the house and later exported it to SketchUp. Let's have a look at the model as is, and without lighting from the LightUp plugin. And because it seems the GLB file exporter doesn't work very well with Paul's model, we're going to first export it to Sketchfab, set it to downloadable, and then get it into the spoke editor using the same method we used with the basic house earlier in this tutorial. Here's the house in Mozilla Hubs. Without any lighting, the house doesn't look very attractive, and so that's where we're going to start. Back in SketchUp, we can see that the model has some useful layers, or tags as they're now called, as well as a large number of unnamed groups in the SketchUp outliner. Because the LightUp plugin uses groups to create light map textures, we need to create meaningful groups manually. We also need to delete all doors to make the house easier to walk through, and delete all transparent surfaces as they can lead to strange visual effects in the walkthrough version of the house. This may feel like a daunting task, but it only took 23 minutes for this specific house design. Here are the groups that we created for this house. Now, let's light it up with the LightUp plugin. On our first try, we didn't really get what we expected, so we cleared the LightUp cache, removed all LightUp info, and exited SketchUp while LightUp was still active. Back in SketchUp, we clicked on Go in the LightUp plugin, and now the lighting looked a lot better. Remember, after a hard reboot of LightUp, you'll need to choose the right render settings again in the LightUp preferences. Ignore cache, use sun, not real time, and custom 3 meters. Once we see the better lighting when rendering at a 25 centimeter resolution, we can then render it at 1 centimeter resolution to get a lot more detail. And thanks to the low sun position, the main rooms are really nicely lit. But over here, we can see that the bedrooms and the basement are too dark. There also appears to be some missing walls and ceilings in the basement. It looks as if the surface of these two planes are transparent and that we are looking at the inside of the wall. The face orientation is wrong, but this is an easy fix with the Auto Reverse Faces function of the Frito Tools extension. With this extension, simply select the incorrect surfaces and perform the Auto Reverse Faces function. We rendered it again and everything looked a lot better. Another thing we did was replace a few of the dark walls and ceilings with white materials, using a texture that was just 1 pixel in size. And here's the lighting after. There are 2 ways to improve the lighting and shadowing in SketchUp so that you get a better result with the LightUp plugin. The first is to add emissive planes outside the building so that the light comes in through the windows. The second way is to add lights to the ceiling and walls on the inside of the building. Both methods have their pros and cons. First, we'll try the emissive planes method. Place large squares outside of the house and next to the windows that are not lit up by the sun. Click on the little light bulb icon. Press the Alt key and left-click on the new squares. A dialog box pops up called Material Properties. Tick the emitter box and leave the other properties as they are. Let's render again at 1 centimeter resolution. As you can see, we now have some very bright lights coming in from the outside of the building. Let's look inside the basement. There's a lot more light in there too. While the lighting looks better overall with the emissive walls, you can see there are still some unnatural shadows. So let's try this second lighting option and add lights inside the house. One way to place lights on a ceiling is to turn the house upside down and add a horizontal section plane. To place a light, click on the light bulb icon, then click on the ceiling. After placing the light, you may need to reposition it. We can use SketchUp's standard tools for positioning lights, making additional copies, and grouping them. To set the lighting properties, click on a light with the light bulb icon selected. A dialog box pops up that lets you select an IES profile. Now, these are industry standard light profiles. Most light manufacturers provide IES profiles for their products, and you can download these profiles by searching online for IES light profile. LightUp includes 2 sets of manufacturer profiles, and you can always add your own. Browse through the profiles and select one that fits your taste. To check the light, we rendered a test at 25 centimeters. It's looking pretty good, so we're going to place lights in the other rooms in the same way. For lights on walls, we can use a light fixture object and place point lights inside of it, which is also a default feature of LightUp. Make the material semi-transparent, and let's see how that looks by clicking Go in the LightUp plugin. For easier placement, we can make a SketchUp component of this set and place another one on the far wall. Let's render again at 1 centimeter. This time, the rendering took 25 minutes, but when it was finished, it was time to fly through the house. Looks pretty good. Next, we'll export the LightUp model as an FBX file. And to get the FBX file and its light map textures into the spoke editor, we need to convert it into the GLB format mentioned earlier. Luckily, one easy method is to import the FBX file into SketchUp again and then use the GLB export extension. To best import FBX files into SketchUp, we tested a few SketchUp extensions. We landed on one tool called Transmuter. This extension lets you import files from various formats and then perform some basic operations, such as setting the vertical axis and the scale, manipulating the materials, and reducing the number of triangles before saving them in the SketchUp format. In our case, we only set the orientation and scale. Transmute the file in SketchUp format, open it in SketchUp, and export it into the GLB format. Now, we need a model to set the collision features in our VR environment by selecting only the floors and stairs. Hide all layers apart from the floors and stairs, and then export these to GLB as well. It's time to bring everything together and finish creating our VR experience. Let's go through the steps together. First, drag the GLB file of the full house into the spoke editor. Then we'll do the same with the model that we made for collision. Set the size and position of these two models just like we did at the beginning of this tutorial. Make sure that the collision model is invisible with walkable and collidable options turned on. And make sure that the full house model is visible with walkable and collidable options turned off. To adjust the floor level correctly, we created a yardstick object at the correct scale and placed a few of these throughout the scene. Create the floor plan and publish the scene to Hubs. And first, we're going to walk through the house with a PC. Share the scene to get its link and code so that you can easily access it while wearing the VR headset. Now, let's check the floor level with the Oculus Quest controllers. The collision level is 10 centimeters too high, so we need to go back into Spoke, set it lower, and republish the scene to Hubs. Once you are happy with the house in Hubs, you can invite other people over for a virtual design review meeting or just for a social gathering. All you need to do is send them the link. People can change their name when they enter a room by choosing Set Name and Avatar in the top left corner. Here's a recording of a social meeting we held in our virtual office. As you can see, we got a little carried away with all the interactive features. Here, you can see the impact that good lighting can have on a model in Hubs. To test our workflow, we created some other VR walkthrough environments from designs made in Vectorworks, Revit, ArchiCAD, and SketchUp. We've left these online for you to explore. The links are provided in the description. VR walkthroughs are a great way to review a design for yourself or with other stakeholders, allowing everyone to get a good grasp of its dimensions, or just for a fun social get-together with friends or colleagues. But when it comes to communicating a design to its fullest extent, Lumion makes it easy to prepare a series of photorealistic videos and pictures that highlight the finer details of your project, all while helping audiences feel and experience the spaces you've designed from the angles that you choose. This concludes our second tutorial on free, web-based wireless VR walkthrough solutions for architects. We hope you enjoyed them, and we'll see you in our next tutorial about creating a 3D scan of a house interior using only your mobile phone. To get a notification when this next tutorial is available, make sure to subscribe and click on the bell icon next to it. I'll see you in the next tutorial.